All right, anytime we have a normal distribution, which is one of these bell-shaped curves, we can apply this 68, 95, 99.7 rule. And it means if we look at the mean in the middle and we go one standard deviation each way, so we have to know the standard deviation. But it's told right here that it's 1,000. So the mean's 20, and again it tells us that here. And you can see from the pictures 20 is right in the middle. So if you go 1,000 more than that, that'd be 21,000, or 1,000 less than that would be 19. In between those two numbers, 68% of the data is. In terms of this problem, it means that 68% of people are going to pay between 19,000 and 21,000. So again, our standard deviation is 1,000. So if we do 2 steps above the middle, so 21, 22, and also 2 steps below 19, 18, between those two numbers, between 18,000 and 22,000, 95% of people pay, in this case, 95% of people pay that amount for a car between 18 and 22. 95% of the data is between those two numbers. And then 3 steps, so 1, 2, 3, 23,000, or 1,000, 1,000, 1,000, gets you down to 17. Between 17 and 23,000, 99.7% of the data is. So this problem is asking what percentage who pay more than 23,000. So 99.7% of the data is between these two. And so let me jump over to a picture I can draw really quick. So as I was explaining, 99.7% of people are going to spend between 17,000 and 23,000, which leaves 0.3% to be either above 23,000 or below 17. As a decimal, that would be 0.003. I think this problem actually wants it as a percentage, so we'll leave it as a percentage here. But 0.3%, if you want to split that up, you'd have either 0.15% of people are spending above 23,000, and then 0.15, sorry, my writing's getting really sloppy with this pencil, it's kind of hard here, but 0.15% below 17, 0.15% above 23,000, and then 99.7% in between. And altogether that adds up to 100,000. Sorry, 100%. And we know our total percentage has to add up to 100%. So that's why this chart makes sense. And that'll wrap up the problem. All right, standard deviation takes a few steps here. I really recommend using Excel or a program like that because it'll just keep track of the math for you and make it a lot quicker. So what you need to do in Excel is type in the numbers. So here's the 12 numbers that the problem gave, and then you're going to find the mean of that, or the average. So you can use that, a quick formula. Let me bring this down here. There is an average formula you can type in. I just did the sum, so add up A2 through A13 and divide by 12 because that's how many there are. So I just averaged them, you got 74.2. Then the standard deviation formula says figure out how far away each of these numbers is from that mean. So I'm just taking each number and subtracting it by 74.2. The next number, so minus 74.2. 64 minus 74.2. So you get all those differences. Then the formula says you just square those differences. So over here, I'm just doing this number times itself. B2 times B2. And then this number times itself equals that. 10.2 times 10.2 equals 104. These will all be positive. When you square a negative, it turns positive. But once you get these, then you're ready to simplify down and get your final answer. What you want to do is sum all of these up. They sum up to 3,467.68. And then you divide by 1 less than how much data there is. That's what it means when you're doing the, where does it say, sample standard deviation. If it was a population standard deviation, we would divide by 12 because we have 12 numbers. But whenever it's a sample, which is what we have here, we divide by 1 less than how many we have. It gives us a better measure of standard deviation. So there's 12, we're going to divide by 11. So we just sum those up, divide by 11, and the final thing is to take the square root of that. And in this case we get 17.8. It tells us to round to 1 decimal. So square root of 315, and I just typed in SQRT for square root, and it gave me 17.8, and that would be your answer.